Hey guys, so today I was given a trick question, which I'm going to go over real quick. Real quick, it's important to note that when we look at this triangle, that it's a right triangle. Because if it's not a right triangle, and you'll see this in trig, you'll be asked to solve a triangle, and you'll have certain methods you can use. It's important to know that this is a right triangle due to this little box here, indicating that it's 90 degrees. Okay. So because it is a right triangle, we can use ka, it's an ugly H, toa. Okay? So you might have heard this before. If not, it'll be a good review. So this is sine, this is opposite, this is hypotenuse, this is cosine, this is adjacent, which means next to. This is hypotenuse, this is tangent, this is opposite, and this is adjacent, okay? So what does this really mean? Well, this first one here is saying, is that sine of theta is equal to your opposite length over your hypotenuse, okay? This one is saying cosine, the cosine of theta is equal to your adjacent over your hypotenuse. And then lastly, this is saying tangent of theta is equal to your opposite over your adjacent. Cool, so we have that down. Now if we look at our triangle, when we're saying the words opposite or adjacent, we're saying that from the perspective of theta. So this 45 degrees right here, that is that's kind of our reference point, if you will. So what is opposite of that 44 degrees? What is adjacent of it? So if you look, we have our degree, we have our adjacent side of 65, and we're looking for our opposite. Can we use sine of theta in this case? Well, we have theta, we don't have the opposite, and we don't have the hypotenuse. So probably not going to use. So what about COA? Cosine of theta. Okay, we have theta, we have the adjacent, we don't have the hypotenuse. You technically could use this after you find your hypotenuse. You could do Pythagorean's theorem to find x, but I feel that's somewhat defeating the purpose of kind of, I think, what the teacher was alluding to, which is we can use tangent, because tangent of theta is equal to our opposite over adjacent. Well, we have an adjacent, right? So we have tan over theta, which is 44 degrees, is equal to opposite, which I'm going to call x, over adjacent, which is 65. And we're trying to solve for x, so all we have to do here is isolate x. So what I'm going to do is multiply both sides by 65. Okay, so those cancel. So 65 tangent of 44 degrees is equal to, so after plugging that in, I ended up getting 62.7. Should be squiggly because that's an approximation, which is about, we were told to in the question, I should have mentioned this, round to the nearest whole number. So that would be 63. So our side x is equal to 63, whatever the units are.